Hey there, welcome to DevOps and Data Simplified. I'm Kalpesh, and today we are going to take a look at a key component of the internet, that is DNS, Domain Name System. We are going to take a deep dive in what DNS is, how it works, and how it is managed by cloud. So let's get started. In this video, we are going to take a look at what is DNS, how it works, what are all the different components of the DNS, public versus internal DNS, what are domain name service providers, how do I register my domain, different types of records inside the DNS, DNS caching and TTL, DNS security, what is a subdomain, its delegation and how it's done, DNS propagation, and cloud provider DNS services. So what is a DNS? What does it actually do? A DNS maps a domain to its IP address so that we don't have to remember the actual IP address while accessing a website. Without the DNS, we would need to type the IP address in the browser to access any website, which would be very cumbersome and ineffective. Now that you know what DNS is, let's talk about how it actually works behind the scenes. There are several steps involved when DNS is resolving a domain name to an IP address. Let's break those and analyze. The first step happens on your device or on the local network. When you enter a URL in the browser or a domain in the browser, it connects with a recursive DNS resolver. The recursive DNS resolver is typically provided by your ISP or a public DNS service provider like Google. If the resolver doesn't have the domain name in its cache, it connects with the root DNS server. These are the servers which stores your top level domains or TLDs like .com, .org, etc. Now the root level DNS server redirects its queries to the correct TLD server based on the extension name that you have. Next, the TLD server directs query to the authoritative DNS server. Now this is the DNS server where the mapping to your domain to your IP address resides, and it returns an IP address for the domain that you have. And once the resolver has the IP address, it caches it for the future use, reducing the time needed for subsequent requests. Now let's take a look at public DNS versus private or internal DNS. Let's break them down. Public DNS is what we use to access any website or service on the internet. For example, Google's DNS or Cloudflare's DNS, etc. Public DNS servers can resolve the DNS names that are accessible worldwide. Now in the private networks, like an enterprise or a cloud network, the private DNS servers are used. These are used to resolve the domains inside the closed infrastructure, like to a VM, to a database, or to an internal API, etc. These are not available publicly. Imagine a company that is running its internal applications in the AWS. Now the private DNS server is responsible to resolve the domain names within that company's VPC, allowing all the internal services to communicate with each other securely. On the other hand, the company's public DNS resolves the domain name like www.example.com for its external users. Now we have looked at the DNS. Let's take a look at what are different DNS providers that we have. DNS providers are companies which allow you to register a domain name and provide tools to access and change the DNS records. These providers offer services like DNS hosting, domain forwarding, and SSL certificates. Some of the popular domain registrars are GoDaddy, Google Domains, Namecheap, etc. When you register a domain, the registrar provides you with the DNS management tool so that you can create the DNS records or configure the services like email and website hosting. Okay, as you can see, I am logged into one of the registrars, godaddy.com, and let's say I have a company and I want to register my domain for it, right? So let's say my company name is my.org sample, and I want a domain with myorgsample.com. So if I go ahead and search for it, fortunately the domain is available and I can buy this, right? If you don't want .com extension, there are different suggestions that are over here. If you want any specific extension from below, you can just go ahead and choose, right? Okay, now let's go to the already registered domain that I have. So this is my domain, which is learnwithdds.in. Okay, so this is a domain which I already registered and purchased. Now what I will do is I'll go to the manage DNS. So let's say I want to create a DNS record, right? Let's say I have my application in one of the cloud provider and I have uh, exposed it using a load balancer. That load balancer of course has an IP address, and then now I have to resolve that IP address with the domain name of my choice. First of all, what I will do is I will go to I'll go to my cloud provider. Let's say for example, I'm using Azure as my cloud provider over here. I log into my Azure account where my domain is, where my application is deployed. I'll go to the DNS zones. Let me create a DNS zone. Yep, so I'll create it with the exact name of my domain, learnwithdds.in, review and create. Okay, I'll go to my resource. This is the DNS zone that I have, and let's go to the record sets. So in the record set, whenever you create a public DNS zone, there will be these name servers that will be added, right? So what you need to do now, in order to bind your domain DNS zone with your DNS provider, you need to register these name servers first. So if I go back in the DNS management of my DNS provider, I'll go under the name servers, right? I'll change these name servers. I'll delete all of them and I'll use new name servers, right? So this is the first one. The second one. Make sure you add all the name servers that have been provided. And the final name server that I have. It will ask me to verify my identity. So I'll just pause the video over here and verify my identity. Okay, once the verification is done, I'll go back to my DNS zone and I'll add a record. So what I want to do is I want my application to be accessed with sample.learnwithdds.in, right? And this is an A record because I want to give an IPv4 address of the load balancer. And let's say my load balancer address is 10.110.10.10. Okay, I'll just go ahead and add this record. And now what we can do is we can go to any of the DNS lookup tool and we can see whether the record is updated or not. So if I go to the DNS lookup tool, just do a refresh, sample.learnwithdds.in. As you can see, this is the A record, the domain name that I have entered, sample.learnwithdds.in, and this is the exact IP address which I have given. Okay, so that means the DNS record is propagated successfully. Now whenever I click https sample.learnwithdds.in, my website should be accessible. Now let's take a look at what are the different types of DNS records. The first one is an A record. This maps domain name to an IPv4 address, and this is the most commonly used record. Second is for the IPv6, that is the AAAA or 4A record. This again maps the domain name to the IPv6 address. Next, the CNAME record. This points one domain name to another domain name, like www.example.com to example.com. Then MX record. This specifies an email server which is responsible to receive an email on behalf of a domain. TXT record, used to store the TXT information. This is generally used for verification or the authentication of the certificates and other resources. Each of these records serve different purpose in the DNS ecosystem, and knowing when and how to use them is a key for effective DNS management. Okay, now before moving to the subdomain, we need to know what is our root domain. So as seen in previous example, the root domain that we have is learnwithdds.in, right? Now let's say this is my company and I have multiple offerings under it. Like for example, I have my food offering or a food delivery service that I have, which I want under the subdomain eat.learnwithdds.in. Then I have an e-commerce company which I want to list under shop.learnwithdds.in. So these will become my subdomains. Okay. Now under the every subdomain, I want to expose multiple applications. Like for example, under the eat subdomain that I have, eat.learnwithdds.in, let's say I want to host gourmet.eat.learnwithdds.in and italian.eat.learnwithdds.in, and under the shop I'll do books.shop.dds.in and groceries.shop.dds.in. Okay, so let's say these are different applications that I want to expose under each subdomain. Okay, now what I will do is first of all I'll need to create these subdomains, right? Eat and shop. So let's go ahead and do that. So if I go again to the DNS zones that I have, what I will do is, this is my root domain, this is my root DNS zone, and let's create a subdomain. Now in Azure, what you can do is, you can, while creating a zone, you can specify if it is already a subdomain of an existing DNS zone or an existing root zone or a parent zone, right? So over here, I'm checking this box and I'm saying that I want to create eat.learnwithdds.in, and which will be the child of this parent, that is learnwithdds.in. What it will do is, it will automatically add, or it will automatically register the name servers of eat.learnwithdds.in in the learnwithdds.in, right? That is, it will add the name server of the child zone into the parent zone, so that the parent zone will treat it as the subdomain, right? Now, as you can see, the zone is created, name server delegation is ongoing. Now, if I go to the DNS zone, I have two DNS zones. Under my root zone, learn with DDS, under the record set, you can see the new entry for the EAT subdomain with the type as name server and the name servers that are under the EAT subdomain that are populated over here. Okay. Now, if I go in the EAT and just do add, now I want to add gourmet.eat.learnwithdds.in and my IP address will be 10.110.11.11, right? I'll add it over here. Okay, my record is added. Now I'll create again another subdomain. Shop. Okay, I'm clicking this is a subdomain which is a child of learnwithdds.in. Okay. The resource is ready. We'll go to the resource. Again, if we go back to the DNS zone and go to the root domain, go to the record sets and see that we have a new entry with the NS record type, and all the NS records of the DNS zone are added over here. Okay. What we will do is we will go ahead inside the shop and we'll go ahead inside the shop, go into the record sets, click add books.shop.learnwithdds.in, my IP address 10.110.33.233. Okay, and I'll go ahead and I'll add this IP address. Now if I go back to the resolver and I'll do the DNS lookup once again for gourmet.eat.learnwithdds.in, do the DNS lookup and yep, the entry is populated 10.110.11.11, right? If we go ahead and verify it, yep, this is the entry, right? And if I go over here and see the record set over here, or the application which is hosted, right? My website which is for selling my books, that is books.shop.learnwithdds.in. If we go ahead again to the DNS lookup, books.shop.learnwithdds.in, do the DNS lookup, and it will give me the IP address that I want, 10.110.33.233. This is the exact IP address that I have. So that's how you can do the subnet delegation of the DNS zones in your root domain. Now let's take a look at DNS caching and TTL. DNS caching helps reduce latency by storing the previously requested records for a specific time, that is called as time to live or TTL. When DNS resolver receives a record, it stores that information temporarily. If another request comes in before the TTL expires, then it will serve the same record from its cache instead of querying again to the DNS server. Now the TTL, or time to live, it basically determines how long the record will be cached at the resolver's end. A shorter TTL time means the updates from the DNS server to the resolver could be propagated faster, but it generally increases the load on the DNS server. And a longer TTL While it reduces the load from the server, it may delay the updates. DNS security extensions or DNS Sec were introduced to prevent DNS queries from having certain types of attacks, like for example, DNS spoofing or cache poisoning. How it works is it adds cryptographic signatures to the DNS records, allowing the DNS resolver to confirm that the data that they have received is authentic and hasn't been tampered with. This is really crucial to prevent the attacks like for example man-in-middle attacks, where an intruder could modify the DNS queries on the fly and redirect user to a malicious website. DNS propagation. When you create a new DNS record or make a change to an existing DNS record, the updates are not reflected instantaneously. DNS changes needs time to propagate updates to all the DNS resolvers, DNS servers worldwide. What happens during the propagation? DNS resolvers that are already caching a record for any specific domain will wait for its TTL to expire before fetching a new update from the DNS server. Once the TTL is expired, the new update will be fetched and entries will be updated in the DNS resolver's cache. This process can take anywhere between a few minutes to 48 hours depending on the TTL that you have configured and your DNS provider. Now let's wrap up with an overview of how major cloud providers like Azure, AWS or GCP handles the DNS. Every major cloud provider has its own DNS service, like for example, AWS has Route 53, GCP has Cloud DNS, and Azure has its DNS zone. With the help of these resources, we are able to create the DNS zones or the subdomains that we want and register its name servers with the domain name service provider of our choice. That is it for today's deep dive in the DNS. I hope it helped you with the basic concept of DNS as well as some advanced terminologies. If you have any questions, please feel free to leave in the comments below. And don't forget to like, share and subscribe the video. Thank you so much.